So I really appreciate this opportunity to talk about what's been not just a project, but really a program in the space of wetland restoration in GBR catchments. Can I firstly thank some people and organisations, you know, the Australian government firstly and foremost for their funding for the NESP program more broadly, but individually for the project that I've been working on now for a few years. The funding's just been so great, and we've been able to advance forward so much our understanding of wetlands, and particularly all the restoration projects that all my end users, my friends who I've listed their logos across the bottom of this slide, really appreciate their input over the last few years. It's been a lot of fun, a lot of great knowledge, and a lot of important information that these groups now will be using moving forward. The area of wetland restoration is only going to increase, and that is really hinging on now the UN declaration last year, where they've stated that there needs to be a halt on the destruction and loss of the world's ecosystems. And that includes coastal wetlands. Wetlands, under the definition of Ramsar, being all areas that are wet, either permanently or at least some point of the year, are considered to be a wetland. The UN has declared that from next year, the next decade, is the time now to restore the function, the utility back into our world ecosystems, and in my case, coastal wetlands, which is really exciting to think that the work we've been doing the last few years and skilling up the end users is now very much ready to deliver on that, at least in the part of the world that we work and know and love. Wetland restoration is also being certainly heavily recognised in government documents now. We have, through many years of hard work, been able to acknowledge the work that's been done, and certainly now there's a big shift to improving and increasing the amount of restoration in coastal wetlands. And this is such an exciting space to be in, and it aligns very neatly with the UN declaration. So we're really quite excited by that. The basis for the work we've been doing the last few years has really hinged on the Queensland Wetlands Program. It's just such a great resource, a great team of people, a collective knowledge that's coming together there. The other states in Australia are very envious of the framework and the information, the platform knowledge that we have now. Really, when we talk about wetland restoration or restoration more broadly in the coastal zone, it's about firstly defining the values and the services. That's really important to think about when you start any wetland restoration project or any restoration project. What's the value? If you have that information and it's agreed to by the stakeholders at the table early on, then your chances of success will be only increased. And I've got some examples I'm going to talk about today through this program. And in fact, each of the restoration sites that I've worked on have started with discussions with the end users. And these are just a small number of photos where we've met in the field with NRM groups, with government, Indigenous groups, landholders, general community, and defined what the value is we want to restore to, what's the service we want to see come back to that particular site. And that's been so important in defining and agreeing to that early on in the project through each of these sites here. I also wanted to highlight in this slide that the return I've given to end users, and this is really a partnership, it has been from day one, the outputs from the program, so the publications and the media, it's all joint. I've got my end users as authors on some of the publications that have been released already and those that are in the pipeline. And the work we've been doing is featuring in internal documents too with NRM groups, NGOs, Indigenous groups, So it's really wonderful to think that this really is a partnership. It has been a partnership from day one, and we're really so excited to be sharing the success today. We know floodplains are wetlands, and they are important in so many different ways. We have floodplains all along the GBR coastline that are connected and disconnected at various stages depending on how much rain and when the rain occurs. The importance of that connection is not just for attenuating the amount of water moving across the landscape and so reducing the risk of flooding on infrastructure, for example. There's a water quality benefit. There are certainly some huge advantages of having a connected floodplain if you think about the biology, so the flora and fauna that utilize these floodplains. And that's what this is really about. It's about restoring the natural processes that occur along our coastal areas and floodplains. So why is that really important? So let me share with you for a minute the reason why this is important. And I want to use the mangrove jack as the case study here. The mangrove jack is a really important species. A lot of our farmers, a lot of our community love to go and target this fish. It's a wonderfully fighting fish. It's very good to eat. It's quite nice to eat. There's a commercial fishery built around it as well. Mangrove jack has a life cycle that starts well offshore. So our coral reefs along the Great Barrier Reef is where it starts its life cycle. The mangrove jack then moves into estuaries and into fresh water, and eventually will return back offshore to complete its life cycle. So having a connected landscape, a floodplain, is so important for this species. And it really highlights the importance of the coastal ecosystems. Although we're modifying and changing in many places, there is a strong link with the reef. And the mangrove jack is an absolute case, an important case study to demonstrate that. The photo I've got there is not only me showing off with a mangrove jack, but that mangrove jack was caught in a wetland, a freshwater wetland on the Tully floodplains. It was about sort of a few years old, I guess, maybe a couple more years, and he'll eventually move back offshore to spawn and complete its life cycle. So having this connection for floodplains is absolutely critical, and that's been a big part of this program to date. We also have a lot of Ramsar wetlands along the GBR coastline, and Bowling Green Bay is an absolute one that comes to the front of my mind. There are so many values and services that the Bowling Green Bay Ramsar wetland provides. You know, here's just a snapshot of just some of the flora and fauna, the spectacular flora and fauna that reside and utilize that particular Ramsar wetland. And importantly for us, it's about protecting the ecological character of that wetland, that Ramsar wetland. If we aren't able to do that, then we all of a sudden have at risk a major internationally recognised important wetland. And so the work we've been doing, particularly with North Queensland dry tropics in the case here, is about trying to build data, knowledge and confidence to better manage that particular wetland. The challenge, though, is if you turn 180 degrees and look back up the catchment from Bowling Green Bay, it is a hugely changed, modified catchment where we have a large amount of agricultural development, sugarcane production that happens there. Yet we still have this expectation that the value and the services provided by the Bowling Green Bay Ramsar wetland will continue into the future. And this really is the challenge that we have now, trying to balance conservation with development. Development's going to happen, we understand that, or it has happened. So the challenge now and the opportunity for us is to better manage the situation. And Bowling Green Bay, as I mentioned, is a really good example of that challenge that we have an opportunity moving forward. So the way this program was set up, initially when I was pulling together the program, I was overwhelmed and very humble by the number of project sites where end users, mostly NRM groups, wanted to partner with us to allow us to do some good science, complete some good science, to build that knowledge and support the success of their restoration projects. And so I approached this in a way whereby there were case studies, and so each of the case studies represented the kinds of wetland restoration projects that we were seeing and continue to see in the GBR. So the first is Mungalla wetland. This is in Ingham, where we have a bund wall, an earth bund wall, which we know occur right along the coastline in many places. And this site was about building on some initial work CSIRO did with the Nwagi Indigenous Corporation there, removing a bund wall to try and reinstate tidal ingress to control invasive plants and improve water quality outcomes. So that was the first case study. The second is working with Jarragan, our NRM group in Babinda, where they had built an off-channel constructed wetland. The idea there is water coming down the catchment full of nutrients is channeled into this wetland, and because we can manually close the system and hold that water for as long as we like, we were looking at whether the water quality improvement could be achieved there before the water was released. So that was a constructed wetland as the second case study. The third is on the Burdekin floodplain, looking at the management of invasive aquatic plants. So we've got a number of study sites there, which we've been working on the last few years. The results are coming through there. At Agnes Waters, Yarimbala National Park, we worked very closely with the Burnett Mary NRM group there and with Parks and Wildlife. This was a wetland, a directory of important wetland, fish habitat that had been heavily impacted by feral pigs. The NRM group there with Parks and Wildlife had built a fence around the wetland, but didn't have the capacity to evaluate the success of that. So we stepped in there to use this as a case study, looking at the impact of pigs on on coastal wetlands. And the last case study is in the last 12 months or so as an extension, working with reef catchments there, looking at ponded pastures as important freshwater wetlands. Although artificial, although built, they are providing an incredibly important freshwater ecosystem service. They are almost the remaining last freshwater coastal wetlands that we have. So we wanted to evaluate that as a case study to look at what value and service they're providing. So they're the case studies. I'm going to talk a little bit about some of them. I haven't got time today to talk in detail about them all, but the reports coming through are released very soon, and I've got a slide at the end with some of the publications as well, which are coming through. So I'll start up with Round Hill. This is the feral pig project. So as I mentioned, this is a Burnett Mary Regional NRM group initiated project with Parks and Wildlife. We were fortunate there to get access to the reserve. This is a directory of important wetlands, fish habitat area. It's got designated jambar and camber status, so a really important and sensitive area, yet very, very impacted by feral pigs there. So the fence went around the wetlands just before we started. And what was really exciting in the first meeting when I went down there to talk with Burnett Mary NRM group and Parks and Wildlife about the kinds of services and values that they have on that wetland now, having completed the fence, they were really interested only in looking at the vegetation recover and wader birds and seeing those recover after that mitigation strategy they put in place, which was great, really interesting. Me being me, I thought we could throw a lot more science at that. So I wanted to add in things like water quality changes, look at the fishery values. I also ran some carbon additionality experiments Not only in that wetland, we had a series of 4 other wetlands nearby as sort of control type wetlands under various levels of pig impact and cattle in the end. So really exciting to start with that. And when I turned up for the first field trip, I figured I'd just get the key to the reserve. However, Parks and Wildlife in particular was so excited that some science was being done on their wetland that they had a team of 5 rangers. We had 3 land cruisers, 2 side-by-sides, and a volunteer with their sleeves rolled up, ready to get into the science. And so for the next 18 months, on each of the trips, we had almost that full complement of team and resources thrown at it. It was just so exciting to think that they were so passionate and engaged in this little bit of science that we did. A brief look at the results. So 2017, after the fence was put in place, not surprisingly, we started to see a lot of the vegetation and the waded birds start to come back, and we've got all the data in the reports there. Water quality was improving, which was great. We started to see fish returning into the wetlands, species that are economically important. We had banana prawns show up there. We had mullet, which we know are commercially important. So things were looking pretty good just within the first 12 months after installing the fence, which was quite exciting. Towards the end of the program, what was really interesting and a huge lesson that we've documented now, the wetland had fewer fish. So this is several years after the fence had been in place. Fewer fish were present. The vegetation had changed a lot. And the reason for that was because of the land tenure arrangement with the adjacent landholder. He has permission to let his cattle into the reserve to feed, graze on the salt marsh. And that's causing, in fact, it's probably undoing all the great work the fence has done, excluding the feral pigs. So the wetland is being compromised by that land tenure arrangement there. So we were quite, the recommendations there were really important for Parks and Wildlife to take that forward as a way of better managing our estate across Queensland, that we need to change some of these land use arrangements. Otherwise, putting a fence up for feral pigs, it really maybe not a great idea given the service that is provided by that wetland with that adjacent farmer. What we also found too, and this matches up with our work on the Archer River, this is with the Northern Australian hub, when you put a fence around a wetlands, keeping pigs out, that's great. But what we also found was our freshwater turtles that need to move across the landscape become trapped inside these fenced wetlands. So all of a sudden you start to think very deeply about the services and the values of the wetland. Putting a fence up is great for controlling pigs, but not so great if our value is about protecting freshwater turtles. So we did some experiments, and we've come up with ways of increasing the chance for turtles to move across the landscape. And we've got the paper in review at the minute. I'll say that I let that turtle go. He was rescued from the fence, and we allowed him to move on his merry way there. So that was another important lesson from that work. We also have used and embraced digital technology, and drones are becoming more and more frequently used in wetland assessment, and certainly make a lot of sense in tropical northern Queensland when we have things like crocodiles that compromise our ability to accurately survey wetlands. So the value of restoring vegetation, which was the identified service Parks and Wildlife wanted to see in this wetland, straight away for me thought, well, we can now use drones to map that vegetation return and change. So we did that through time. The beauty of drones and the flight paths, and then the ability to analyse, classify that information, allows you to very accurately see the change or recovery through time. So we were able to embrace that technology as part of that work. I want to jump to Mungalla now. This is in in Ingham, where we have a earth wall that was built in the 1940s, and it's got this wonderful, sad indeed, history, legacy of change and Indigenous connection with country there. The wall was built in the 1940s and became a big barrier, a large barrier for tidal moving into that into that wetland. Consequently, on the upstream side, over time, became a freshwater wetlands. We have seen the last 20 or so years invasive freshwater weeds choke that area. It's become compromised as a habitat for birds. Water quality is certainly deteriorated. Fish, well, there aren't very many fish living in there. So CSIRO and the Ngawagi Indigenous group about 10 years ago started a project looking at identifying where they could breach the wall and allow salt to move back into that wetland, control the weeds more naturally as opposed to using herbicides and pesticides. And as a way of trying to reconnect the floodplain, fish moving back into that wetland. And some initial results were very, very pleasing in 2011 and 12, where the tide was getting in there, the job was being done. We were seeing the wetland starting to come back to life. In the words of the Ngawagi elder there, it was coming back to life. Very, very, very pleasing to see that. However, that was only a couple of years of data. And if you look at restoration ecology and the literature around that, if you have a degraded state and you're heading towards your desired state, in between that, those 2 points, is going to be variability. So this presented the opportunity for me to continue on that work and track the recovery of this wetland. And so now, to this day, we have about 9 years of data, by far the longest monitored wetland recovery in the GBR. And we've got some an amazing understanding of this wetland and the recovery of that. I'll give you some information on that just briefly. So the data set we have now shows very clearly that the wetland, although salt does get in there, that happens on those dry years. So if we have an average or below average rainfall wet season, the tide can get into the wetland and do its job, and the time-lapse camera there shows that. However, if we have an average or above average rainfall year, the freshwater, the hydrology coming down that catchment doesn't allow the tide to get in. So the wetland goes back to this freshwater dominated state again. And we see the weeds coming back, unfortunately. So this has been a huge and great amount of knowledge now that we've been able to glean over those now 8 years. We wouldn't have had that knowledge if we only had 3 years of funding just to do that initial bit of work. We would have ended up with maybe not quite right, the answer that is right for this particular setting here. To add on to this project, what I wanted to do was add some more hydrodynamic modelling. So CSIRO did some great work there looking at under sea level rise, how much and for how long will the tide get there in the future? And we ran a series of scenarios, and basically just a 50 centimetre increase in tide, we're going to see not 3 connections of salt a year, but up to 12 connections of salt a year. So the hydrology is changing. The amount of tides getting in there will increase under sea level rise. And that has some really important consequences maybe, or outcomes for fishery connectivity, and maybe even blue carbon possibly down the track. So maybe there's no or very limited blue carbon opportunities now, but in the future there could be some opportunities there. The Burdekin floodplain was the third case study, and this was really looking at the management of aquatic weeds, which are and continue to be a big challenge on the floodplain. You know the Burdekin floodplain, it's one of the largest agricultural floodplain developments in Australia. We have 80,000 hectares of sugarcane production. We have, I think there's something like 1,000 kilometres of distribution channels moving irrigation water, nutrient-rich irrigation water across the floodplain there. And so it's not surprising that we have this continual need to manage aquatic plants. We need to do that because the hydrology, the ability to deliver water across the floodplain, is compromised if you have weeds choking up the distribution channels. We have water quality issues, we have hypoxia, and we have fish kills every year happening there as well, not to mention the nutrients and sediments and pesticides and etc. that we know are in the water there. So Crooked Waterhole was the target site here. This was teaming up with Greening Australia. They have funding to look at restoring connectivity on a part of the floodplain. We know that in the lower Crooked Waterhole, there's mangroves and there's barramundi down there. We know that from previous work. We've got lots of sugarcane development immediately around Crooked Waterhole. And we know that there's lots of aquatic plants there and compromising dissolved oxygen levels. So very, very low, few fish in the creek itself. So there is some huge problems there. And indeed, we do see fish kills happening there in the wet season when we have flow moving all this low dissolved oxygen water across the floodplain. Unfortunately, fish can't escape fast enough, and the result is major fish kills. So 2018, this was the condition of Crooked Waterhole, and our water quality assessment showed that there was, in fact, very little, if any, oxygen available for fish. The only species of fish we could catch in there were invasive fish that have the ability or mechanisms to deal with poor water quality, low oxygen levels. So very, very degraded state. However, after the huge amount of water harvesting machinery went in there, removed, I think there was 5,000, maybe there was 5 tonne, I can't remember the exact details, of material. Almost straight away, we started to see oxygen levels return. So the life was being brought, the creek was coming back to life. We were resuscitating the creek. Oxygen levels were returning there. So that was great to see that. The reason for that is we have a much smaller organic load on the creek there. So fewer aquatic plants, oxygen levels can return there. What was great to see, the first wet season, the first connected wet season, we saw the return of barramundi. These are a small little sort of first year barramundi returning back into this creek system, which was just so wonderful to see. And then a few months later, about 6 months later, we returned to survey again, and those barramundi were growing quite fast, it seems. They were getting up to sort of 30 odd centimetres in size there. So great to see that with those works done, the water quality is improving. We're starting to see the fish come back, which was the value that the local farmer and the community that wanted to see there. They wanted to see barramundi come back, and we were able to show that. The problem with that particular site has been that the maintenance, the long-term maintenance for this site is becoming quite challenging. And now the project's finished and the responsibility for maintenance has moved to the farmer. This was agreed to early on. And for reasons, I guess, I'm not sure, financial possibly, farmers hasn't been able to keep on top of the maintenance, and we're seeing the creek unfortunately return back to becoming overgrown with aquatic weeds. And I think this shows, which we documented, a really important learning, that restoration is great. You get to see some wonderful results, but we do need to make sure that there is a long-term maintenance funded model in place. And the example which we documented in the Burdekin was Sheep Station Creek, where you have a riparian management agreement between the water boards, local landholders, the council, NQ Dry Tropics. Each year there's a funding bucket available to continue maintaining the aquatic plant growth. And that model is so important and really the blueprint we should see for other parts of the GBR coast. If we're going to invest in restoration, we need to make sure that there is an effective and ongoing maintenance program that will continue to protect the asset being the restoration work there. So that was a huge learning, maybe not surprising, but certainly good to capture that and learn from that. Sticking with the Burdekin, we've just started some work looking at drying out some of the palustrine wetlands. So these are sort of the upper, very upper estuarine areas, over delivery of fresh water from irrigation areas. We've seen that there's weed chokes happening there. So rather than using chemicals again to control that, if we can have intercepting recycle pits, preventing that fresh water getting into those coastal areas, we will see them dry out, weed chokes removed, and we'll start to see mangroves and salt marsh coming back. So this project's really only just started in the last 12 months. Some promising results already emerging. We've already done some vegetation assessments using, again, drones to map out the area of vegetation change. And this is really a watch this space, because I think this is going to be a really exciting project in controlling the hydrology, drying out our palustrine areas to achieve multiple services outcomes there. As part of the team, we've had Dr. Fernanda Adam from Griffith Uni also running in parallel some nutrient processing in wetlands across the GBR landscape, and some really exciting results showing the water quality denitrification potential of our coastal wetlands. So there is certainly a water quality benefit wetlands provide in terms of processing the available nutrients. And so there's been a series of papers that have come from that, which has been really exciting to see, and really moving forward this opportunity to utilise constructed wetlands, particularly to intercept and treat water coming off our catchment areas. So it's been really exciting to see that come through this project as well. So overall, the key messages from this work, I really want to make sure that it's important to recognise that we need to define the goals and agree to those goals, the restoration goals, early on with the stakeholders. It really does set the trajectory of success at that point. Make sure we do that, absolutely, and that's been a big focus for this program today. Define how and when we're going to measure restoration success. Really important to make sure we do that, we get that right, and science allows us to do that. We are able to measure and evaluate the success of those projects, and from that you can leverage, get potentially more projects in this space. So really important that happens. Communication is critical. I mean, I think we all know that, but really important to recognise that it's important to be talking and communicating with our network of friends that we have in this area often, and making sure that information and that sharing of data reports is end user relevant, to make sure that it actually has impact. Maintenance, I've talked a bit about that, absolutely critical for all projects. We need to make sure that's built into any projects into the future. And share the learnings, publish the details, and even the failures. And this is a comment I see a lot in the literature and talking to colleagues overseas that are working in wetland restoration, that it's important to publish the failures as well, because we can learn from that. So the second part to the presentation that Julie asked me to talk about was the land use transition work that we've been doing. We started off by identifying and mapping marginal, low-lying, high DIN generating areas in the wet tropics. That project and report was finished in 2017, and it's great to see that work hitting the ground and leading to projects whereby we are really taking advantage of those poor performing marginal areas for cane and converting them back to wetlands, in particular, providing water quality benefits. We've been able to secure a bit more funding through NESP to extend that work now into the dry tropics, and that report's due very, very soon. We're working through that, and there's been some really interesting and exciting differences in the work in dry tropics compared to the wet tropics. So the concept of taking cane out of production is, well, it was a few years ago a potentially very controversial concept, but when you actually look at some of the mapping in Google Earth, this is certainly happening anyway. There is already areas that are marginal. Cane farmers are trying to get some return, but they're just not able to. And this is an example. I won't say where this is, but where you can see across those sort of 13, 14 years, what was productive land now, next to mangroves, we're starting to see the soil and loss of production there. So why not try and turn that into some other way of investing and getting some income for farmers through potentially some sort of wetland reef credit scheme or carbon market scheme. And that's what this project was about, trying to identify those areas. And then with Jim Smart, who we'll be talking shortly from Griffith, what are the economics around that to realise that? And in fact, this whole idea of building wetlands to increase production in marginal areas has been around for a few decades. This is the SIPS program on the Tully, where farmers were building wetlands, using that material to elevate adjacent and turn it into productive cane areas. And the consequence, positive, you get a wetland there, which the farmers, if you talk to them now, they are still there in many cases. And they're proud of their wetland. They catch mangrove jack. They see barramundi in these wetlands. They're providing a little bit of a water quality benefit. So we're already doing that. And so I think now the opportunity moving forward as a real game changer heading towards water quality targets is identifying and incentivising this transition away from marginal areas to a wetland that's providing some service, either water or some other biodiversity outcome, carbon possibly as well. So just a quick overview, we had looked at available mapping. We had a multi-criteria analysis in place. This is for the wet and the dry tropic projects. We've looked at transitioning the land to alternative cropping, which does show a little bit of promise, but the costs for that is a little bit high, and it takes time usually to get to marketable size. So there are some disadvantages with that. Grazing, we also looked at. There's some opportunities there for converting it to grazing and providing a good income to cane farmers. But by far, and Jim will talk more about this next after this presentation, building wetlands for the purposes of water treatment, the cost $20 per kilo DIN reduced. We've worked harder on that now. Jim will talk about that. This is 2017 data. So that's the cost for a kilo of DIN reduced to build a constructed wetland. If it's about a wetland for ecosystem services, so fish production, for example, it's much cheaper to do that. It's about $10 per kilo of DIN reduced. The reason, in some cases, it could be as simple as removing a bund wall and letting the tide back in, which is why it becomes much cheaper. To put this into context, we have the extension program, which Queensland government have indicated it is about $50 per kilo DIN reduced. So all of a sudden there is a big motivation and an incentive for looking at restoring wetlands, building wetlands in these areas, and it's much cheaper and you get some return possibly for farmers. The Babinda wetland is a case study which we looked at as part of this work. And it's showing that it does provide a level of water treatment, which is quite exciting. It's off channel, so you can control entirely the hydrology. So that report is almost coming through now. And it's exciting to see that the technology is catching up as well. We've got trials that have been underway or being completed, looking at bioreactors. We have algal ponds, there's floating wetland concept ideas. These are the kinds of technology that are coming along, which could provide water quality benefits for farmers under reef credits, let's say. There's a payment mechanism there, and we're improving water quality. So really exciting times to think that this is all emerging, and really only emerging in the last couple of years, this idea of other ways of improving water quality runoff. There's lots of interest in this space. There are more wetlands being built, have been built under the Wet Tropics MIPS program. The data for that, I believe, is coming out soon. We're quite excited to see that data. And we have a lot of NGO groups that are excited at this opportunity to invest in these kinds of restoration projects. And I've only listed a few there that I've been talking to over the last couple of years. I wanted to end on making some strong points around the outcomes from this program. The science has been fun. It's been very interesting, and I've learnt a lot. But for me, it's been always about sharing and working in partnership with our end users and friends, really, that I've established over the years. There are so many presentations and media newsletters, short articles that I've generated as part of this. I'd hate to guess how many there are, but there are, you know, nearly, well, upwards of 100, I would say, that I've done over the last few years, but with pleasure, working with the partners to help them communicate results to their landholders, to their community. It's been really quite exciting. Publication outputs. So there are 10 papers we've published already. So these are already available. They're in the system, and that's been generated through this program. As I mentioned, I have end users on these papers. I think absolutely they have injected so much intellectual knowledge, have helped in the field and contributed to the writing and the analysis of data. So I'm really excited to have them and quite humbled to have their names on these publications. We have another 5 that are in review at the minute, and I know there's another bunch of papers that are going to fall out in the next 6 months. So if we're using this as a metric of success, then there's many of those coming out and are out now. I'll shamelessly do a little plug for international outreach. I was successful late last year in securing the Queensland Government Smithsonian Fellowship, which commenced in February, March this year. I was lucky to spend a few weeks at the Everglades Research Centre, where they're dealing with agricultural development, water quality challenges impacting on coastal areas. So absolutely exactly the same kinds of challenges that we're tackling here. I was fortunate to spend time chairing some of their big events there that they had on harmful algae, providing an international perspective on that. However, and then I moved up to Chesapeake Bay to look at, you know, what 40 years, 50 years of restoration looks like. But unfortunately, it was unplugged in March. There's a lot of interest in the Great Barrier Reef and what we're doing here. And so lots of people are very interested in this space. So I think that's a really exciting opportunity for us. I've mentioned government. A lot of the work, I'm regularly in meetings to make sure the data and the learnings information is fit for government use and end user adaptation and change for those kinds of mechanisms. So it's always in the front of my mind, and there's various reports where that has been the case. I've been fortunate to work across hubs as well, working with the Northern Australian hub. So the knowledge in this hub has been shared across Northern Australian hub, and the Marine Biodiversity Hub have asked me to present several times the knowledge that we're collecting here as well. So there's been some really exciting cross-hub collaboration that has also emerged in the last few years. My last slide, I promise. Key messages. There is now a real need to not just focus on your restoration site. We really need to think about a whole of system, a whole of catchment approach now. We know weeds are a problem, fish barriers, there's water quality challenges. We know that, and we know there are solutions. But the challenge, the opportunity really for us now is to think about the solutions at a scale of catchment. We really need to think about that. If we don't, then the risk is we have isolated projects that are disconnected and might fail because they're not connected in some important way. Collaboration, resource sharing has been a big part of the work I've been doing, and I think that's so important to continue that, particularly as we enter into the decade of ecosystem restoration. If we want to be leaders, in this space, then we need to make sure that we are sharing those resources and that knowledge, and we can get very serious about achieving some of those restoration goals that we're seeing come through. The continued investment is important. We've spent the last number of years investing in this space. Lots of work's been done by NRM groups, continues to be done, but they need support. They need that science support. So I really strongly urge that the future funding rounds consider the need to continue investing in the asset, the knowledge asset that we now have. And we're already looking at market mechanisms as ways of doing that. So I think there's some important benefits there, partnering with markets that are looking to fund restoration and joining that with government programs as well. And coordination and science support is critical. I hear that all the time when I go to meetings, that we need good science to support what we're doing. And with that knowledge and that power and confidence that we have, we will see more projects, more successful projects in this space. And as I say, we're on the doorstep of the Great Barrier Reef. This is an important asset. Managing our catchments, our land, and delivery of water and the biodiversity ecosystems to the reef is so critical. And we need to make sure that we don't lose that focus. So again, I'd like to thank the funders for this program, the Australian governments. I'd like to thank RRRC for your support over the last few years, absolutely. But lastly, also, and most importantly, really, is the end users. They've put in so many hours, so much time into this program, and I really hope that it's provided a positive trajectory moving forward. And I think we have, and I think we're on a really good step moving forward.